So today we are taking a second look at the Nestworks C500 CNC machine, and I can genuinely say I don't think I have felt as much pressure put on me to get a second video out as I have with this one. You've been chasing me constantly for it. Now, just as a reminder, there is a part 1 to this video. I'll put a link up in the corner to it, and that runs through a lot of the high level specifications about the machine and the advanced features of it. But in this episode, we're going to take a look at the different projects and testing that I've been doing with the machine, cover off a lot of the common questions that have come up since my first video, and then ultimately tell you the things I dislike about it, the things I like about it, and the things I absolutely love about it. So let me begin by covering off why this second video has taken so long to come out. Well, ultimately, due to a mix of user error and some questionable advice from Nestworks, this happened. I completely destroyed the ATC, including the tool setter within it. Now, as annoying as that was, what it actually did was highlighted a small bug in the firmware itself, and they were genuinely amazing at fixing this and rolled out a new update to the software within like 48 hours. They also agreed to send me a new ATC, so ultimately I had to wait for that to arrive. But despite the accident, it actually gave me the opportunity to do some testing that is quite relevant. Now, the ATC can't really take any bits with a bigger head than around 7mm, ultimately due to the diameter of the holes inside it. So for example, if you wanted to use something like a surfacing bit, a bowl bit, a point roundover bit like this one here, they won't actually fit in the ATC, and you need to use it manually like you would a normal CNC machine. Now, one thing that happened on the launch day for this product was there was a bit of confusion around the work area. Ultimately, some of the sizes that were printed about it were inaccurate, and Nestworks corrected these as quickly as possible. But there is still some confusion around it, so I want to try and clear things up as best I can. Now, the first thing I will highlight is the reason the confusion comes around this is because as part of the entire work area, well, there are multiple zones within it. You can start to understand why there are so many different references for the work area because, well, there's a lot going on. So I wrote them all down just to try and be as clear as I possibly can. The entire bed size itself, effectively the maximum piece of material you can put on there, is 375mm wide by 250mm deep. Now, in terms of the actual work area, without the ATC, this is 230mm wide by 220mm deep, and with the ATC, that is 165mm wide by 220mm deep. So hopefully that does help. Now, one thing I will just point out as part of this, because the touch probe is offset to the spindle, if you are maxing out that work area, you can't actually use the touch probe to identify the center of the material. So it's just one thing to bear in mind, that if you're using smaller pieces, absolutely fine. If you're looking to max out that work area, then you can't really use the probe for identifying the center of the material. In terms of the rotary, you are looking at around a maximum length of 150mm for the working area. Now, the rotary is offset slightly outside of the working area, so it can take longer pieces of material, but the working area, as I say, is around 150mm with the ATC in place. If you remove the ATC, I think you can get a bit more out of that, maybe 170 or 180mm in terms of the maximum working length for it. The diameter, or the maximum diameter it can take, I think is around 90mm, obviously depending on how you clamp things within the jaws themselves. Now, there were some questions around the validity of Nestworks appearing to be a new company, so I just want to cover that off. Now, technically, Nestworks is a new company, but they're actually a branch off, or a sister company to Elephant Robotics, who are a much more established company in the robotics industry. Now, the way it came about is they needed a machine to do their prototyping and R&D, and ultimately they couldn't find one that met all of their needs. So they built their own, and that's basically where Nestworks spawned from. So those of you with any doubts that the company doesn't have, I suppose, much hold in the industry or much background to it, well, that is the reason why. They do have a lot of background, they just branched it off as a separate company in order to do the production of the CNC machine. So let me cover off some of the common questions that have come up since the last video went out. Well, one of the most popular ones is, can this use bits from other brands? Now, basically, the collet on the spindle is a standard ER11A collet, which means it will take shank diameters up to 7mm wide. So as long as your bit is no bigger than 7mm on the shank, then it will fit in this absolutely fine. As mentioned earlier, if the head on the bit is larger than 7mm, then it will not work with the ATC, so do just bear that in mind. Now, there were some questions and concerns around the thread action of the ATC changeover. Now, it's worth highlighting that this is not the first machine to use this type of action. There are multiple other machines out there that basically do it, so it is tried and tested. Now, because this is a standard ER11 collet, the nuts on the collet should be softer than the thread on the spindle itself. So if anything is going to go wrong, you should just be able to put another standard nut on there and carry on using it. But I can genuinely say that since aligning the ATC correctly, I haven't had any issues with the interchangeover of the bits themselves. So I do have confidence that it is tried, tested, and is going to be durable. Now, I did cover this in the last video, but ultimately there were still a lot of questions around it. What CAD/CAM software can be used to run on this? Well, ultimately, the firmware that underpins this is just a modified version of Gerbil, which is basically an open source firmware that most desktop CNC machines operate on. So that's pretty good news for all of the users. So it basically means that your most common piece of software, such as Carveco, Fusion 360, Vectric, are all going to be able to output files that you can run on this machine. Now, it is worth highlighting you will need the correct post processor to do that, but as I say, Fusion 360 is already out. I already have the one for Carveco, and that should be out in their next release, and I dare say Vectric will catch up in the near future. A very quick personal plug from me on Carveco. Hamilton Dilbeck and myself recently created Carveco Academy, the official training platform for Carveco CNC software. Now, we've released a Jumpstarter course targeted at beginners to get you up and running, structured content, easy to follow tutorials, lots of free project files to go along with them as well. We're also giving away 600 free AI credits for Carveco as part of signing up for that. So if you are a beginner with Carveco and are struggling, definitely check out the links down below in the description area. Now, even though I've been putting the parameters up on screen of the different projects and tests that I was doing, it's worth highlighting a couple of them specifically. Now, I will say that I don't go for optimal chip load when doing this. I just keep pushing the machine deeper and faster as part of doing the review because I want to know what the machine can actually handle. Also, for consistency, for the most part, I've tried to use the same diameter bit when doing these specific tests, which was a 6mm end mill. Now, that's either typically been with a 4 flute or a 3 flute. Now, I was doing a speed and depth test on some aluminium where ultimately I ended up going 1.2mm deep per pass at a speed of 1200mm per minute. Now, I still believe that could have gone deeper and faster, but ultimately that was the point that I stopped at. I was machining the side of some aluminium at 14mm deep per pass with a step over of 1mm, and I was doing that at a speed of 2000mm per minute. So basically taking 1mm off per pass of 14mm deep. Now again, I think I could have pushed that further, but I was starting to see that the finish on the material wasn't as good, so I decided to stop there. The nautical wooden plaque, I did this at 3mm deep at 2000mm per pass for the rough cut, and then I did the tapered ball nose bit at 1mm per pass at 1800mm. And a lot of you want to know about steel. The hardest piece I had in the workshop was 304H stainless steel, which I think has a rating of up to around 270 HB in terms of its hardness. Now, I was machining this at 0.4mm per pass at 900mm per minute. Now again, it probably could have gone a little bit faster or a little bit deeper, but ultimately I was noticing the finish wasn't looking as clean as earlier, so that is the point that I stopped. Now, I couldn't test any titanium because I don't have any in the workshop, but it's worth pointing out that the 304 stainless steel is harder than the titanium, so basically anything that is less than that, it's going to machine it absolutely fine. A lot of you wanted to know how noisy the machine was, so I did some testing basically just using my phone. Probably not the most accurate, but it is what I had. Now, take into account that my small wooden shed isn't the best acoustically, but basically the results that I were getting between around 75 decibels up to around 85 decibels at the loudest, obviously depending on what you are machining and how aggressively you are pushing it. So accuracy and precision, a big question I know you want answers for. Now I do cover myself at this point and just say I'm testing to the best of my knowledge with the tools that I have, generally measuring to hundredths of a millimetre. Now the first few tests that I'd done was all coming up undersized by about a tenth of a millimetre, a little bit more. First question at this stage, is it me? Is it the machine? So I started measuring the diameter of the bits I was using, my measurements within the software itself. Now I did notice I had an allowance turned on from a previous job that I didn't need on this particular one. So turned that off, recalculated the job. Now before rerunning the job, I also checked the backlash and repeatability of the machine. Now whilst the repeatability was perfect, it was always returning to the exact same spot. What I did notice was that each incremental movement, the total travel distance was getting incrementally less. So basically, if let's say it was 1 millimetre short on the first movement, it'd be 2 millimetres short on the second movement. Now, we were only talking hundredths of a millimetre on the actual testing, but what that usually means is the resolution on the stepper motors is slightly off. Now, I don't normally adjust the step resolution for machine reviews because I always try to do it as factory standard. But in this case, knowing the answers that you want from this video, I decided to recalibrate them based on the settings that I had. Now this is really simple to do. It's just basically a quick calculation. You put the new settings into the machine. But ultimately at this point, when I then continued to run the next test, everything was accurate to within 100ths or 200ths of a millimetre. So that is basically what they're advertising. And once I adjusted those steps, I did get it to the precision that they are saying it can achieve. Let's talk about the software. I'm going to split this into two halves because there is technically two halves, the control element of the machine and the CAD CAM side of things. We'll begin with the CAD CAM. Now, as I mentioned earlier, I have used Carveco for most of my testing, but I still have tried to do some jobs within this. Now, the 3-click smart system that they have in place, it does actually work. You can load your model into your software, you can tell it what tools are in your ATC, and it will do its best to basically work out what tool is going to be most efficient in order to do that. Now what I would say is, whilst it is good, I don't think it is perfect. I was trying to do something with a slight radius to it and it was selecting a V bit as opposed to a radius end mill for it. So I think there are some bugs that need ironing out. But it is worth pointing out that this is their basically first iteration of the software, and for what it can do at this stage, it is pretty impressive. When you take into account the amount of years of history that some of the most established companies have behind them, like Vectric and Carveco, well, considering this is their first iteration, it is in a very good position. As I say, there are still some things to work out, but ultimately they have a bit of time before you're going to start receiving your machines, and therefore it should be in a lot better position by the time you come to start using it. Moving on to the other half of the software, the control side of things. Now this is pretty much all positive. It does exactly what you need it to do. You can use your jobs directly from Nestworks Studio or load in G-code from elsewhere. See all the lines of code, see the visualization as well. You can also obviously control a lot of the elements of the machine directly. So for example, turning on the MQL, turning on the air filtration, turning the lights on and off, and you can do this all live as well whilst the machine is running. So as I say, it is very useful and a very easy way to be able to control all the various features on the CNC machine. The only thing really that I've spotted so far that I would like to see is manual overrides of the feeds and the speeds. If you're doing a job and you think it's running a bit too fast or a bit too slow, currently you have to stop the job, regenerate the G-code and go again, whereas a lot of other software out there at the moment can have manual override. So for example, if you think it's going a bit slow, you can just speed it up and ultimately get it in a much better place. So Nestworks, if you are listening, it'd be great to see that in the future. Now, unfortunately for this video, I haven't been able to review the 4th axis like I wanted to, but ultimately my first impressions of it is it's very solid, it is very smooth in terms of the gear ratio and mechanisms going on with it, and the way it's holding the material again is extremely solid. So basically, anything that you can machine on this, you're going to be able to do on the rotary device as well, and it's definitely an accessory I would consider getting if you are looking at the different bundles. So was it a perfect experience? No, there have been some issues along the way and some bits that I've fed back to Nestwork about this machine. So I'm going to highlight those now, as well as the response from Nestwork. It is worth saying that pretty much every piece of feedback I've given to them, they have taken on board and accepted that it needs to be improved. First is over time I started noticing debris started building up on the y-axis ball screws, not necessarily on the ball screw itself, but generally getting into the area where those are, which obviously when you're machining things like stainless steel is not a good thing. Now it's worth highlighting that the actual way they're sealed off, it is pretty good and it does minimize hardly anything getting in there, but at the end of the day, if debris is getting in there, it may cause issues in the future. They took that feedback on board and they have already said they've developed a new way to add extra protection to it and ultimately minimize the amount of debris getting in there. A little bit of a bonus clip. After recording that original content, Nestworks sent me an additional email with more information about the changes they've made underneath the y-axis. I thought it was worth sharing with you because ultimately you're the people potentially looking at this machine. Now they've made two changes to it. The first is installing additional felt strips along the sliding blocks for the y-axis to ultimately stop any chips and debris getting into that area, which was basically my main concern. The second change they have done is also installed a bit of a step lip system underneath there as well. And what this should stop is any cooling fluid that if it does breach that initial area, well then it still keeps it safely contained in the correct area of the machine and stops it getting near those ball screws. Now, I can honestly say I used a lot of cutting fluid during the machining of the stainless steel and I didn't actually notice any seeping into that area. But the fact that they have made that additional improvement as well, I think just highlights that they are trying to get this machine as close to perfect as they possibly can before it reaches you. So thank you Nestworks for making those improvements. The second issue, there are two ways to automatically identify your material on the bed using its software. The first is the inbuilt camera where it will position over the bed. You draw a rectangle over your material and say, there it is. It will then use the probe to basically find the edges of it and identify the center and the top of the material. That all works absolutely fine. The second way is an inbuilt laser that will scan the bed itself and ultimately identify your material as well as any other objects on there. Now, this has been a little bit hit and miss. Sometimes it does it okay, and if you just have your material on there, it will do it fine. But if you start having clamps and things, it's not quite intelligent enough yet to detect the difference between the shapes. Now again, they have accepted this. They already acknowledged that they knew about that and are starting to work on fixing it and basically refining the process. So again, by the time you receive this, I would hope that is going to be in a lot better position. But the joy is that you've still got the backup of the camera option to simply highlight your material for finding the center of it. The third issue is connectivity. I did struggle to get my machine to connect to the laptop via Wi-Fi. Ultimately, in the end, I had to do this via hotspotting off my phone. It wouldn't do it via my natural house Wi-Fi. Now, I will say, I do have a lot of Wi-Fi issues in this shed. There's generally a lot of Wi-Fi traffic in the area. So ultimately, that is probably the reason for that. Now, the other side of that is the USB. Now, at the moment, some functions of the machine are not available to work using the USB cable, which does sound a bit odd to me. So basically the camera positioning that I mentioned earlier for identifying your material, that only works over Wi-Fi. Now they did basically say the reason for this is the data transfer rate via USB at the moment is too low to use the camera at the same time. But again, they are working on this and it should all be sorted by the time the machines are released and sent out to people. So I'm hoping it was an isolated thing to do with me and connectivity, but ultimately that is an issue that I did run into. Now I did mention in the previous video about the alignment issue on the ATC and that I had to recalibrate it. Same thing when I got the new ATC, I had to obviously recalibrate that as well. It does take a couple of minutes to keep aligning things on top of each other, and I've printed myself out a little 3D part that did help. I will put a link to that down in the description area. Now, off the back of me having to do that work and manually realign things, they did acknowledge that it wasn't the best process for achieving it and are actually working on an automatic way or an automated way to align the ATC. I don't know if that's going to be with a probe or something, but ultimately I'm looking forward to seeing that upgrade because it's going to make your lives much easier in terms of, just being able to click one button and it will recalibrate the whole ATC. So yes, I have found some negatives and teething issues, but that is expected. That is why they send prototypes out ahead of the full launch. I think the impressive part is the way that they have acknowledged all the feedback I have given and either already found solutions for them or are working on solutions for them ahead of this going into full production. So it really says a lot about Nestworks, and I genuinely love all the features on this machine. The ATC, I've never used one before. It makes life so much easier just to have a multi-tool job, click one button, let it run, and it does all the hard work for you. When you combine that with the facilities to be able to identify and find your material on the bed, the probing feature to be able to center it, to be able to surface it, it just makes life a lot easier for a CNC user, speeds the process up, and ultimately just makes things much more efficient. I genuinely can't stress how much thought has gone into this machine on pretty much every single element of it. Little things that you wouldn't even think of. The feet, for example, they're designed in a way to absorb extra vibration. Now, vibration is one of the largest causes of noises on CNC machine. So it's just those little things to help minimize that aspect of it. As I say, I am honestly blown away by the amount of effort and thought gone into this, especially for their first machine. The quality and durability of the enclosure, they've clearly not tried to cut corners by the different hinges and bracketing that they've used as part of this, which makes a big difference, especially to the noise. The fact that you can operate it via the touchscreen, your laptop, your PC, even your phone, and yet they've still bothered to integrate the option for an MPG, knowing that is what some people prefer. They've genuinely tried to cover off and think of everything, and it is truly the most advanced CNC machine that I've ever seen in person and used. So that is probably the right point to end this review on. Now, I've tried to cover off as much as I can in the time that I've had to do the testing, but if you've got any more questions, let me know in the comments section down below. I will continue to keep posting about this on social media when I'm doing more tests, and there is a good chance I'll probably have another video out about it early in the new year to start talking about the updated software and additional features that they have inbuilt into the machine. So definitely keep an eye out for those. And of course, links for this machine will be down in the description area and the comments section. So thank you all very much for watching. Final thanks as always goes to my patrons, and I'll see you all on the next episode.